So you can give the values as such, or you can mention this is constant. Okay. Now we have to check the grammar for assignment statements. Okay. The grammar for assignment statement will be given as a context-free grammar. Syntax analyzer will refer that grammar, and you can easily say this is the valid assignment statement. So the same thing syntax analyzer will also do. Now it will try to generate a syntax tree or parse tree. You have that operator precedence rule and all, no? So which will be executed first, which has to be executed first? You have to process left to right, right? And in the left to right, you have to take the operator precedence, right? So rate into 60 has to be done first, executed first. So in the parse tree, this construction of parse tree will be done by this parser or syntax analyzer. There are two types of parsers are there. One is top-down parser and another one is bottom-up parser. Okay. So there are different types of top-down parsers. You will study that. And similarly in bottom-up also we are having three types, right? And based on the precedence, let me take, just I'm giving a rough way of creating this parse tree. I'm taking bottom-up parser. So from this statement, I can observe that rate into 60 has to be executed first. So I'm taking the leaf node as id, 3, which refers rate, and 60 refers the constant. So this is operand 1 and this is operand 2, and the operator should be taken as the parent for these two operands. So this job will be done first. Okay, that is in level 3. Now the resultant will be taken as one operand, and what operator we have to do? We have to add it with init. Init is referred by id, 2, right? So that id, 2 that refers init, right? So that will be taken as operand 1. That will be added. So for adding, the parent of these two operands is plus. So that will be added with operand to this value, and the whole thing will be taken as a right-hand side result, right? So we have completed right-hand side assignment expression. So the result has to be assigned to the left-hand side variable. Okay, so the left-hand side variable is position, right? So the position is represented by id, token id, 1. It refers actually position, right? So that is equal to, that equal to is used for assignment statement. So what did you infer from this? In the parser part, you don't know about what is the name of this identifier, what is the name of this identifier, what is the name of this one. Just it's have an idea. We are having 3 operands. One operand is to store the value, and 2 operands are used for, 2 identifiers are used for calculations in the right hand side expressions, and one constant is used. Okay, so these are all the things we are studying in this parse tree, parser, right? Our syntax analyzer. So you can successfully generate a syntax tree. Yes, my job is over. I'm giving the syntax tree to the next phase, right? So this is a rough example for this assignment statement, identifier equal to. You can represent like this also. There are different ways of generating parser statement. What is the difference between the first tree and the second tree? Can anyone tell? In the previous tree, what did I give? Just go through this tree, right? This is tree type 2. What is the difference between these two? Yes. We are adding some more flavors to that parse tree. It's given that here in the previous tree we have just given this is an equal to, this is a plus, which is a parent of these two, right? But here what we are doing is, right, instead of giving equal to here, I'm taking this as giving brand as this is an assignment statement. This is an expression, right? And for under this expression, we are having the operator plus, like this we are giving. Okay, similarly, there will be an elaborated tree structure for this also. 8 into 60. Okay, fine. Clear with this? Next one is semantic analyzer. So in the semantic analyzer, that syntax tree is taken, right? Now that syntax tree will be analyzed to check the assignment operator what you have given can be carried out at the time of execution. Will it lead to any error? So for that we have to perform type checking, right? So the type checking will be done here. It will check all the operands, what is the matching operand or what is the operator given here. If I am giving plus, it has to take two integer values, or it has to take two float values, or it may be either one integer or float like that. And all these things will be analyzed in this semantic analyzer, right? The next phase is intermediate code generation. So in the intermediate code generation, the tree what you have generated, that is abstract syntax tree you might have generated in this semantic analyzer, no? So that will be converted into tree address code. So in that one, first we have seen rate into 60, right? So we have done it, no? So you have to, if I find that all these floats, rate is given as float, or position is a variable of type float, right? Our initial is also a float. All these three variables are float means if I am performing this operation, what I have to do is, since this is an integer, that should be converted into float. So for typecasting, that might have done in this semantic analyzer itself. So that flavor is added in that syntax tree. That abstract syntax tree might be given as input to this intermediate code generation. So in your syntax tree, it might be like this: star id comma 3, which represents rate, and in the place of 60 it might have into float. The type checking and adjustment or type coercing might be done in will be done in semantic analyzer part, and all these things, this will be integer or float like that. Every type will be added with that. That abstract syntax tree is given as input to intermediate code generation. Right. Now, this expression, what is given as a branch of that tree, should be converted into tree address code, right? So first what I have to do is I have to perform this conversion. For this conversion, I am using one temporary variable t1, integer to float conversion 60, right? Just imagine this t1 is going to hold some value. It may be it may save this value either in memory or register. Which one you will prefer most? Memory or register? If I want to concentrate on speed, if I want to reduce speed, I have to go for register or memory. Students, are you there? Students, can you hear me?
Yes, ma'am.
Yeah, tell me, which one you prefer, memory allocation or register for reducing time?
Register, ma'am.
Register. Okay. So I am using one temporary variable. It may refer a register. At the time of machine code generation, you can represent that instruction as a register operation, right? Instruction, register to register a movement, right? Assignment. So here I am taking T1 is a variable, right? So this T1 variable will hold the value of 60. The constant 60 will be converted into float, and that value will be saved in T1. Next, we have to perform this star, right? That is multiplication of ID3 with T1. That will be saved in T2. Next, the T2 will be added with ID2. That will be saved in T3. And the result will be saved in position, that is ID1. So the same that syntax tree is converted into the corresponding tree address code. Okay. So now it is easy. Now you can check it out. Is there any way to reduce the codes and all? That will be done by code optimizer, right? So instead of having 4 lines, the code optimizer has converted like this. right? Instead of saving your writing your program as 60 and then converting into integer to float, I can directly give the input as 60.0. So it will automatically convert that into 60.0 and it will reduce one line here, right? Integer to float, that one line is also reduced, that instruction space is also reduced, as well as this T1. We have to use it for holding that intermediate results, no float value, right? So the T1 as well as that instruction time is reduced, and we are rewriting the sentences T1 equal to ID3 into 60, right? And ID2 is 2. What is ID2? T2 is having ID. This is replaced by T1. Okay. Now ID that value multiplication is done. Then directly you can add these two values, right? So that's what done here. ID2 plus T1, and the result is saved in ID1. Okay. Clear with this? So the objective of code optimization is try to reduce the variables used there, to reduce the space, as well as try to reduce the instructions count, as well as you have to choose the simpler instructions, right? Okay, which will run fast. Okay, the next one is code generation. So my target code is assembly code, right? So here I am generating an assembly code. First of all, I have to load the value of ID3 in one register, LDF, and multiplying that with R2 with 60, that's a constant, and then load ID2 in register 1 and perform register addition R1 plus R2. The result will be saved in R1 and store the value what is present in the register to ID1 memory location. Okay, clear? Can anyone tell, already you might have studied computer architecture, right? Can anyone tell what are the other ways to reduce this code? Because we are going to have one more phase, code optimization in this target code level, right? How can you reduce it? Can anyone suggest any optimization steps in these 5 lines? No, because we are not using any looping statements and we are using only registers, so it's not used here, right? In case if you need some optimization at this level, we have to do that also, right? And we are having two more thing. One is error handling and another one is symbol table. So I have already discussed this. Error handling will help you to detect the errors in each phase and report that errors. And this one, symbol table, is used to find what are the variables used and the associations between them, right? It not only saves the record in that, also it will tell you where are these variables used are referred in the consequent lines, all the lines of the statements, all the lines of the program. Okay, so it's very, very important to have a complete flow analysis of the particular variable. For example, line number 1 is having integer d1. If that in d1 is used in line number 10, that should be saved. Line number 22, some other statement is using d1, means again that should be saved. The complete flow analysis will also be done, and that is also a part of your code optimization phase, right? It will try to analyze all these things. Then at the time of code generation also, it will try to do that. Why? Because only if you analyze that, you can come to know which are all the variables are not used one, or which are the records we need not save till the end of your program. All these analysis will help you to remove the waste spaces occupied by some of the variables in your program. Okay. So the symbol table, this is a data structure which is containing all the records, and it is used to find the record for each name quickly, and it is used for all the procedure names, everything, not only variables, procedure names, as well as if you are using some functions, that function name and the location of it, and what are the variables you are using inside the functions, that will be stored in one activation record. Once the control comes out of that execution of the functions, all those variables will be vanished, and you have to come back to your main control, main function control, right? Again, you have to go through with the variables present in that main, right? For that and all, we are using the stack, right? The stack, we are having a stack data structures which will keep the activation record for each and every functions. So all these things are related to the symbol table. So the complete history of all the variables present in your program will be available in symbol table, right? Go through this once. What is the input? A statement, lexical analyzer, syntax analyzer generate this first tree, semantic analyzer add type checking, intermediate code generator, code optimization, and final code generator. Here I didn't mention code optimization in the code generator level because this is a very simple statement, but actually that is also a part of it, right? In general, they are telling these are the 6 phases of compiler. We are having a more optional statement which is code generation optimization or optimization in the target machine code level. Fine. Any doubts? So whatever may be programming language, all the programming language have their own syntax rules, their own grammars, right? So based on that, your front end will be varying from one language to another language. So this may use different rules in syntax analyzer. This may use different ones. So the front end part is varying from one language to another language. But once if it generates the intermediate code, then the remaining optimization as well as target machine code generation is common to all irrespective of language, whatever you are using to write your source program. Okay. Normally, a compiler is not taken as a single pass, right? In rare cases, we are having that. Actually, if you study that system or software, you might have known about this. What is single pass compiler and what is for multiple pass, right? In the first pass, we don't know what are the variables. If you are using microprocessors, in the microprocessors, the variable declarations will be at the end of the program. Did anyone use that microprocessors lab? You have studied microprocessor lab, right? No.
No, ma'am.
No, right? The program will not be like the one what we have, what we are seeing in our high-level programming language. In our high-level language program, first we should have a declaration variable. So that declaration variable should give all the informations about the variables, whatever we are going to use in your program. And only if you allocate space for that, you can use use that variable inside your program. Okay. But in the case of microprocessor code, microprograms, what we are having is you will have all the set of instructions, and finally you will have to load the last line, right? For example, it is starting from 0th location. First instruction is taking 4 bytes. So the fourth one you have to give the next instruction. 8th you have to give the next instruction. Like that you will give. Once if you get that call statement tells you the end of the program. Once you reach the end of the program, next address, right? For example, it is the 16th address, right? So it will, if it takes a 0, it maybe takes only 2 bytes, or it will come to 18, right? Here you have to load the first variable. If I'm using one variable here, R1, right? So the variable and the corresponding value will be saved. Okay. Similarly, if it takes integer, if it is an integer means it will take 4 bytes. So 22, again it will go for the next variable. Likewise, it will save all the values, right? So what it will do is, in the first phase, it will go through, in the first pass, it will go through all the instructions, and wherever you are using R1, it doesn't have any idea about this R1. What should be filled up? Because we are converting into machine code. From this microprocessor program, that program should be converted into machine code by assembler. That translator is used there. So when the assembler is translating this code, it doesn't have any idea about this R1 at all. Only if it goes through till the end of this halt, and it will start reading this all these data present there, then it comes to know, oh, this is R1. The R1 is holding the value 0 and its address is 18. So in the second pass, it has to fill that 18th address. The address of R1 is 18. So 18 will be replaced in the place of R1. The corresponding memory address, wherever you are using variable, the corresponding memory address will be replaced. So this type of translator is using two pass, right? So normally a multi-pass compiler will be having more than two pass, right? The first pass, it will do all these pre-processing. You might have used hash include, all the macro programs, everything will be expanded. Macro programs will be expanded, pre-processing statements, hash include, has defined, everything will be done in the first pass. In the second pass, it will generate what it will do. It will read the character strings, it will go through front end, and it will generate IR code, right? And then optimization phase, and the last one is target code generation. You can have your pass like this also. Okay, these are all the cousins of compiler. So if I have to use compiler, I need the help of all these things. That's why it's called as cousins of compiler. I need a preprocessor. I need assembler, because sometimes the target code what you are using, that is in your program, in your compiler, is assembly level code. So again, that assembly level code should be converted into relocatable machine code. So I need assembler. Okay. So what I'm telling to what I'm giving here is your input source program is there. First, it has to gone through preprocessor. It will free from all the macro calls. Everything is over, right? Now you will get a source program. That source program will be compiled by compiler. It will generate assembly code, because my target code is assembly code here, right? Again, I cannot use this assembly code as such to execute the program. So I need an assembler which will convert this assembly code into relocatable machine code, right? So what I mean by relocatable machine code is, when I am generating instructions in the form of machine code, I have to give the address of it, right? Instead of giving the correct address in the memory, like 3000, 3004, 3005 like this, I'm going to give the instructions like the 0, 4, 8 like this. Okay. Now, if I give my instruction address like this means, then the loader, you can save the program anywhere in secondary memory also, right? Once, if you want to execute your program, it is in a form which is ready for execution. If I want to execute, I have to move that program into main memory, right? So at that time, if I have a space in the main memory in the address 6000, I can just load it here, load this first line here, 6000. So it will automatically convert, right? 6000 will be taken the 0th instruction. So next instruction will be saved in 6004, like that. So this loading will be done by loader, as the linker will help you to link with all the header files around the subroutines. If you are using any functions in your program, that linking will be done by this linker. And what is the use of debugger? What is the use of debugger? You might have studied OS, right?
Ma'am, it will find errors in the code.
Yeah, error. It will help you to debug it.